All right, we've just got a couple of problems now in chapter 10 to work through. The first is problem 8 against the sister problem 7, both on page 60. And this is about solving quadratic inequalities. And I think I've tried to get across to you that solving inequalities can be tricky. And that's the bad news. But the good news is that if you just kind of have in the back of your mind some of the graph properties associated with the quadratic inequality that you're trying to solve, it makes things very simple. And I'll demonstrate that right here, right now. Problem number 8 says solve x squared plus 3x minus 10 is greater than 0. So when you see a quadratic, you just can't help but try to factor it. I see a 2 and a 5 that makes a 10, and that it additively can make a 3. So I believe I can turn this problem into x plus 5, x minus 2. The 5 and the minus 2 make the 10. 5 plus the minus 2 make the plus 3. And so these are equivalent. And so you can sort of, if you were interested in finding the zeros of this equation, and as it turns out you are, you can see immediately that x equals minus 5 makes this monomial factor equal to 0, and x equals 2 makes this one equal to 0. So the two real zeros that are associated with this quadratic are minus 5 and 2. So if I just quickly do a little sketch here, here's the point minus 5, 0, this intercept, and here's the second point, 2, 0. Now let's stop right there for a moment and think a little bit about what we know about the graph. If we look above, if we think about the graph of this quadratic, it is a quadratic that opens up, because the coefficient here on the x squared term is positive 1. And it goes through these two zeros. So without drawing any details, I know that this quadratic looks like this. It opens up, it's got a minimum below the x-axis, goes through these 2 points on the x-axis. So when we just look at it, these intercepts divide this space from minus infinity, from x goes from minus infinity to infinity into 3 parts. There's a part here where this function, I'm gonna just call it f of x to have a name for it, where this function is positive. Yeah, it's above the x-axis. There's a region to the right of the point to 0, or to the right of the line x equals 2, where again this function is always positive. And there is a region between x equals minus 5 and 2 for which this function is less than 0. And so that tells us what we're looking for. We're not looking for the region where the function is less than 0, but rather the region where the function is greater than 0. And that's these two regions. In particular, it's x belonging to minus infinity to minus 5, union with x in the interval 2 to positive infinity. And so without carrying the algebra any further, all we've really done is find the roots and then appeal to the graph of the function to write down the solution to the inequality.